I love the suggestion right there. Let's check it out. What about the cosine of 90 degrees? Here we have a right triangle with an 18-degree angle, right? And when that happens, the adjacent leg is always 95.11% of the hypotenuse. It's almost practically equal to it. But let's actually make that acute angle a little bit bigger. Let's go like to 29 and let's see what happens. If that acute angle measures 29 degrees, well, that percentage goes down a little bit. That adjacent leg is only roughly 87% of that hypotenuse. And would you look at this? The more and more, the bigger I make that acute angle, the less percentage I have, the less percent of that hypotenuse that adjacent leg actually takes up, believe it or not. So let's go all the way up. Let's approach 90 degrees. At 60 degrees, the adjacent leg is half of the hypotenuse, is it not? See what I mean? That percentage is still going down. Doesn't matter how big or how small that right triangle is. When that acute angle is 60, the leg adjacent to that acute angle is always half the hypotenuse. But let's keep going and let's see. Let's make that angle bigger and bigger and bigger. And let's make it 72 degrees. Look at that. That's a tiny 30.9%, right? So the adjacent leg is only roughly 31% of the hypotenuse. But as we keep going up and up and up, look at that adjacent leg right here, that adjacent leg right there. Its value is approaching 0. So then ultimately, look at that, 85 degrees. Oh my gosh, the cosine of 85, that's only taking up 8.72% of the hypotenuse right there. It's hard to tell what side's the hypotenuse now. But let's make it 90 degrees. Oh my God, that triangle just disappears. Since that adjacent leg disappears, it vanishes, its value is 0. And 0 divided by any non-zero number is always 0. So that's why the cosine of 90 degrees is always 0.